The next problem, find the residual velocity at infinity if the velocity given to an object from the earth surface is n times the escape velocity. So we know what is escape velocity, the minimum amount of velocity required to escape from the earth gravitational pull. So residual velocity, we need to find the residual velocity at infinity. So at infinity in the condition infinity, potential energy is zero. So the velocity given to an object, so from the earth surface how much velocity is given in the sense n times the escape velocity. So n times the escape velocity. We can do this problem by the conservation of energy. So we can use the conservation of energy, initial minus final. So initial kinetic energy, from here the kinetic energy will be 1 by 2 m v square. So here the v is given, initial velocity u is given n times of escape velocity. So yeah, I'll write the initial velocity 1 by 2 m u square initial, and then potential energy initial equal to kinetic energy final plus potential energy final. So I'll substitute the values here. So 1 by 2 m u is given by n times of ve square plus potential energy. We know the formula for potential energy in the gravitation, minus gmm by r. So final kinetic energy, this is what we need to find, 1 by 2 m v square. From this we need to find final potential energy, infinity the potential energy is 0. So we need to find this v. So here what I am going to do, simply in all the terms m is small m is present, so I can simply cancel out this one. So if I need v square, so how can so v square is equal to this 2 I can take an here for both terms, 2 by 2 n ve square minus 2g capital M by r. So this 2 get cancelled. So v square, I will write here, v square is equal to n square ve square minus 2gm by r. So can you remember what is this formula? So if we did that, we already know the derivation for escape velocity, in that ve square is equal to 2gm by r. So this is the formula of escape velocity square. So I can use this here, v square is equal to n square ve square minus ve square. So next step, I can take out ve square common, so we'll get n square minus 1. Now we need the v only, so taking square root, v is equal to square root of ve square into n square minus 1. So on the next step, this can be cancelled. So final velocity v is equal to v square square root of n square minus 1. So this one is the residual velocity. Thank you.